Wonderful. Yeah, thank you. Can you make me host? Our co-host is also fine. I need to start the recording. Okay, let's start. In the meantime, friends, sorry for the delay. All right, friends. So, good morning, everyone, and thank you for joining. As part of the interview preparation sessions, this is the third day, or you can say session 3. And in the day 1, we discussed about basic statistics or statistical inferences, crisp DM related queries, interview related questions. We tried to cover as much as possible from the crisp DM steps. Yesterday, we were discussing about data mining, unsupervised learning related questions. Now, today, we will talk about data mining supervised learning techniques, or you can also say predictive analytics. We'll focus on predictive analytics concepts. So let us start. Question 1. Whenever we talk about predictive analytics, the first question is, what is inferential statistics? What does inferential statistics mean? Yeah, first question, guys. Inferential statistics. Very good. Fun. Statistics is really a concept which is basically telling us on conditions for population. Inferential statistics. We infer conditions or statements for population, for generic population. But in order to do this inference, we need to look at sample data, because we cannot get population data. We get sample data, and we perform our statistical calculations on sample data. So the results, which are called as the statistics, are used to infer statements for population. That is known as inferential statistics. Next. In order to do inferential statistics, we need sample data, right? So what are the techniques that we know for sampling? Oh, okay, my voice is breaking. How about now? Is it still same? Okay. So sampling techniques, we can broadly name them as biased and unbiased, right? Biased and unbiased. And we also call them as probability and non-probability techniques. And we already have come up with all these things in the book, right? And a lot of people are taking advantage of this book. You should also take the advantage. There's the book. Yeah. Just expanding this. Structure, unstructured, right? All these things are basically what we discuss in our sessions. So in a structured way, all these things are explained here, right? Random variable, probability, inferential statistics. You can see here, biased sampling, unbiased sampling, probability or non-probability sampling techniques. And yeah, you can see here, non-probability sampling techniques, probability sampling techniques. There are few points mentioned here. All right. So sampling techniques. Next. When you're trying to do inferential statistics, the first thing probably you will attempt to do is hypothesis testing. What is hypothesis testing? Why is it used for? Why is hypothesis testing used for? Or what is it used for? It will take time, Kiran. We are preparing that. We underestimated the effort that goes into preparing a book. It's still under development. We are still preparing that. So it will take some time. Yeah, for making decisions or not? No, for making decisions. That's it. What decision is depending on the business problem. To draw insights about population, okay, comparison of two data sets, okay. Yeah, hypothesis is a form of inferential statistics, of course, yes. No, inferential statistics is basically to estimate a condition. Hypothesis testing is basically helping you to identify whether that estimation is acceptable or not. So hypothesis testing is proving whether the chance of the estimated value is falling in the accepted region or not. Can we accept the value or not? Right? So hypothesis testing is a measure of our estimation being true or false. Now, when we talk about hypothesis testing, we immediately have to talk about, inferences, or I should say hypothesis statements. By default, what is the default condition called as in hypothesis testing. Null hypothesis, very good. It's the default condition, or it says continue what you are currently doing. Now, if this action that you're currently doing is wrong, then we go for alternate hypothesis. Right? That's represented as H1. Okay, next. What conditions should we, or I should say, what is the condition called as when we take action even if the significance of the test fails? Yep. Even if the condition is false. Yeah. Very good. Type 1 error, which is represented as alpha. Type 1 error says taking action even when it is not required. So whenever we talk about hypothesis, immediately you have to come up with this table, right? So we have H0 here, H1 here. Here also we say H0, this is the true conditions, assume, and this is H1. Now if H0 and H0 are true, then this is called as, what is this condition called as? Condition, name. Confidence, very good. And it is represented as 1 minus alpha. It's called as confidence. And this is type 1 error, which is represented as alpha. Now, if H1 is true and H0 is considered, then this is type 2 error, which is represented as beta. And what is quadrant called as? Power. This is called as power of the test, and this is 1 minus beta. Right? So this table you have to by heart with respect to hypothesis testing. This is something that you have to embed into your brains. So I'll ask a question on here. What is type 2 condition? Explain type 2 condition. You should be able to explain. Yeah, what is type 2 condition? When the current condition that we are performing is false, but still we continue doing the current action. That's when your type 2 error occurs. That means you need to take action, but you're not taking the action. Failing to reject a false null hypothesis. Right? That is type 2. Okay, what is criteria? What is the criteria for concluding on decisions? What is it called as? What is it called as? Significance level. 1 minus alpha is confidence. Alpha is significance, and this is the criteria we are talking about. This basically says the chance of, or I should say maximum chance of going wrong, which is accepted. If you go wrong beyond this, then yes, it is not accepted. So the criteria for conclusion is this parameter or this metric, right? We call it as level of significance or significance level. Now, question to you all. The default significance level is 0.05. Very good. But can we alter the criteria of significance? Yes, we can. Rule of thumb says 5%, but we can also have 10%, we can also have 1%, we can also have 8%, any random number based on the business requirements. Right? Okay. What is the process of hypothesis testing? Steps to perform hypothesis testing. Yeah. Very good. So you have to generalize, guys, not for continuous and discrete, not like that. You have to generalize the process here. Crisp DM, remember the crisp DM logic, okay? Business understanding, which basically helps us to frame the hypothesis, null hypothesis, then collect the data. Here we are collecting the sample data. Then we perform the test. That's your mining, data mining. And we get the random chance or likelihood of the estimate, right? Probability. And based on the probability, we will conclude. That depends on the level of significance. Right? Those are the steps, high-level steps. All right. How do we take that decision? What are the decision parameters? Decision parameters in hypothesis. Yeah. Decision parameters in hypothesis. Decision parameters okay, null hypothesis, alternate hypothesis, and significance level, guys, alpha. These are good enough for us, right? Test statistic would be there. The test statistic will give us the chance, probability, which is likelihood of the estimate, right? And based on the level of significance, we basically go about accepting or rejecting the default condition, right? What are those conditions? How do we interpret this? If the significance level, p-value, is greater than the industrial standard 0.05, then we say P high null fly. P high null fly. That means go with the default condition. If significance level is low for the test, then you say P low null go. That means you can take an action. Yeah. Next. Yeah, next. What is parametric test and what does non-parametric test means? Parametric versus non-parametric, yes. Let me write that. What is parametric test? Or test? We are estimating a parametric test. Non-parametric is done to check which parameter can be applied. No guys, come on. Anyone, what does parametric test and what does non-parametric test means? Okay. So parametric test assumes that the data follows normal conditions. Parametric test looks at the distribution of the data. Right? We make assumptions about the distribution of the data, and based on that, we try to make the inferences. In non-parametric test cases, we do not look at the distribution of the data. That's the primary difference. Can you label names and give some examples? Parametric test cases. T-test, Z-test, P-test, ANOVA test, ANOVA test. All these are parametric test cases. Non-parametric test cases are your chi-square test, Mann-Whitney test, Moore's median test, Kruskal-Wallis test. These are non-parametric tests. Yeah? Parametric and non-parametric. Okay. When do we go with T-test and when do we go with Z-test? When should we use T-test over Z-test? When the population standard deviation, which is sigma, is not known. When we go with, then we go with T-test. If we know the population standard deviation, then we go with the standard normal statistic, Z-test. Yep. Oh, next. What will I do, or what test will I go with? What test should I apply for two populations, two normally distributed populations having same variances? Yeah. So what test should I go with? Two sample t-test. Very good. We go with two sample t-test. Okay. What is paired t-test? Paired t-test. When external conditions are same that we used, okay, wonderful. Very good. So paired t-test basically is applied on normally distributed data for comparing the populations of normally distributed data, which are of course continuous, right? And I should say, when the external conditions for both of these populations are similar, right? When conditions will be similar, we apply this paired t-test. Very good, Lokesh. Next, let me write another question. Okay, what is anom test? Full form is analysis of means, but what does anom tell us? Anyone? How is it different from ANOVA? Okay. Analysis of means is basically trying to tell us which of the sample means, and when we have multiple populations, basically will help us identify which from the population mean, overall mean. Okay. This is the yeah, is it now. Okay, let me just check. Huh? Yeah, give me a second. I'm just trying. Still not okay? I just changed my connection. Now okay, right? Okay, yeah, fine. So we are talking about a norm test case. A norm test case basically is used when you have greater than two populations and we are trying to compare mean 1, mean 2, mean 3, so on and so forth with respect to population mean. Right? Which of the means of the populations are statistically different from the overall mean? And when you perform a norm, generally you'll get a norm output, graphical representation of your population mean and your regular means. And you'll see which of these populations or which of the samples that you have is very different, statistically different from the overall mean. That's a norm test case. Right? Okay. Next. What is ANOVA test case then? We discussed about a norm. What is ANOVA? ANOVA means analysis of variance, right? It is used to check if the means of these populations are statistically different from each other. We are verifying whether the means are different from each other, whereas a norm tells whether these means are different from the overall mean. Right? So that's the difference. Yep. Okay. What will be the parameter, or what would be the metric, I should say, that is used in non-parametric test cases? Yeah. For doing conclusions, what is the metric that is used? Yeah. Non-parametric test cases, what is the metric used? No. What is the underlying assumption, the first assumption that we do for non-parametric test cases? Yeah, good, Funny Kiran. What is the underlying assumption, guys, to begin with for non-parametric test cases? Okay. The first underlying condition is that the data is not following normal distribution. Exactly, data is not normal. So you cannot go with mean comparisons, right? We cannot go with mean comparisons. We have to use median here. Yep. What is F statistic? How do we calculate that? Very good. F statistic is basically the ratio between groups, the variability between the groups over within the group variability. Right? We take sum of the squared distances of the within group values within the group data points, right? Over, between by within, my bad. Error, MSC is in the denominator. That means we are looking at within the group variability in the denominator and among the variability, among the group's variability over the numerator. So it is MSTR treatment, mean square treatment over mean square error. So when I say treatment, it is the sum of the squared deviations between groups. So I should say X bar minus mu, grand average. Sum of the squared differences is what we take. And this is X minus X bar whole square. Right? So this is how we calculate F statistic. Now, what can be the range of F statistic? Yeah. Range. It's a statistic, it's not a probability, right? Yeah. Can it be negative? Very good, Lokesh. F statistic will always start with 0. It cannot be negative. Because why? You can simply see you're taking squared values, so you'll never get negative in this calculation. This is an interview question that we can, it can be asked. Right? So it can never be negative. All right. Now, let's talk about yesterday we started with this, right? Evaluation techniques. Now, how do we measure let's say the goodness of it for any, let's say, model, any supervised learning model. Yeah. R squared. R squared will be there for regression, right? I'm talking about supervised learning techniques, any supervised learning techniques. Right fit, how do we get that right fit? Training and test accuracy, errors, guys. We evaluate the models based on the errors, error metrics, right? So evaluation of a supervised learning technique how does evaluation of a supervised learning technique is done? So it is by comparing the actual work predicted. Because in supervised learning techniques, we will know what is the variable of interest, right? So we will be comparing the output, right? And when we do the measure of deviation, we will come to know which model is performing better. So here we call it as error functions. Yeah, we can call them as error function. Right. We've discussed about k-means also, right? Let me ask a question. What is the difference between KNN and k-means? Yeah. What is the difference between KNN technique, KNN classifier technique, and k-means clustering? Very good. Kiran, Bhavna, very good. Suresh, very good. Yes. KNN is a supervised algorithm, supervised learning technique or learning approach, whereas k-means is a clustering approach, clustering algorithm, which is unsupervised. So one is used for predictions or classifications. The other one is used for descriptions, right? Descriptive statistics. Wonderful. And what else do we have? Let me think of. Okay, we'll talk about I'm just thinking of, shall we go with, okay, decision trees. Well, let's go with the decision trees questions. Okay. What all the nodes do we have in decision tree? Very good. 3 nodes. There are 3 nodes in decision tree. Isn't it? Root node, branch node, and then we have leaf node or terminal node. Right. Decision trees are classifiers only. Very good. Santosh, wonderful. Decision trees, or I should say types of decision trees. Yeah, what are the types of decision trees? There are 2 types of decision trees. Classification-based decision trees, regression-based decision trees. Exactly. So your decision trees can work both on categorical data and continuous data. Right? So there are 2 types: categorical variable decision trees, continuous variable decision trees. Okay. What are the major questions that we need to look at? Steps. What are the steps to be performed for developing a decision tree? What are the major aspects that we need to look at? Very good. We have to identify the variable which helps us get least entropy, maximum information gain. Statistically, we will be calculating the maximum information gained. Or in simple terms, we need to identify the attribute which is used to split the data so that we get the most homogeneous pair of branches. Right? So the steps are: identify the root node which gives us the most homogeneous branches. Right. Now, what are the advantages of decision trees? Advantages. Very good. Interpretability, understanding basically. Yes, distribution of the data is not important. That is, outliers are not affecting the output. It can be used both as regressors and classifiers. Very good. It can also be used for factor analysis. Which factor is more important for your output variable? Right? So that is also another advantage that we have in decision tree. Now, what are disadvantages? Overfitting, that's the first thing that we need to talk about when we say decision trees. Overfitting. In fact, decision trees are the algorithms which are most prone to get affected by the overfitting. I mean, it's the algorithm which is most prone for overfitting. But how can we control the overfitting in decision tree? Very good. Pruning. What is pruning? Very good. Pruning means cutting the tree, and types of pruning, we say pre-pruning and post-pruning. Very good, guys. Very good. Okay, what does entropy calculation means? What is entropy? Measure of impurity. Entropy is nothing but measure of impurity or measure of variability. Very good. What can I ask? Okay, what all parameters what all arguments that can be used for decision tree growth? Yeah. Very good. Depth. Number of leaf nodes. Number of leaf nodes or okay. Okay. So there are multiple variables. We'll start with depth, of course. In fact, how many samples should be there? How many nodes should be there when you are splitting a branch, splitting the branches? Right? If you're splitting, then how many records, minimum number of records should be there in each of the branch? That's one of the parameters that we consider. Then we can also say minimum samples that are required in the terminal node also, not just at the branches, but at the leaf node, at the end leaf node, how many samples or how many records should be there? Yeah? Depth of the tree, of course, you already know. How many branches? Total branches from root node. And maximum number of terminal nodes also something we can pass on. And how many features should we consider? How many variables should we consider for partitioning? If you have 20 variables, should I use all the 20 variables or should I use only 10? That is also a parameter that we can apply. Yep. So these are various arguments that are used for fine-tuning your decision tree algorithm. Okay. What is R package? Do you remember R package for tree development? Very good. Only C50? Do we have any other algorithm or package? R part, okay, one of those popularly used. Very good. C50. R part. Oh yeah, very good. One which is another one which is very commonly used. The basic ones. Tree, C tree or tree. That is also very commonly used. Tree. In Python, we have sklearn algorithm. In Python, there you have function called tree. Right. So those are basically commonly used functions for trees. All right. Let's now look at, okay, how do you improve decision trees accuracy? Pruning, okay. Santosh, good. By using ensemble techniques. We use ensemble techniques. Yeah. What all various ensemble techniques are known to you? Yeah. Boosting, very good. Okay. Voting, stacking, boosting, bagging, variants of bagging, variants of boosting. Yeah. Oh yeah. There are different ensemble techniques. Very good. Wonderful, Kiran. Okay. What does stacking means? Combining different algorithms into one. Okay, not really. Meta learning. Okay. Use heterogeneous algorithm. Okay. Okay. Stacking basically is combination of multiple models. What we do is we combine multiple models, right? And we predict output. Same output, right? Same record. new record. We are trying to predict the output using different techniques. Now, what we do is we take these data as input for your meta model. These will be inputs, and what will be your output? Observed data. Observed value, which is y, actual value will be the output. So meta model will take this as input, this as output, and it tries to predict the final output. So you will have supervised learning techniques trying to predict the output, but those output values which are obtained by these base models or base learners, their output will become input for the meta model. Right? So that's stacking for us. Now, what is voting? What is voting approach? Yeah. Going for majority, used for classification, combining predictions of different algorithms, weighted average. Okay. So voting basically is a technique which is applied for taking the aggregated output. It gives us aggregated outputs. All right. So we take either mean or median for the multiple models output. Right? We develop multiple models, and on each of those models, we basically pick up the output, and then we do aggregation. Now, voting can be classified into two types. What are the two types of voting? Hard voting and soft voting. Very good. So what is the difference between hard voting and soft voting? Hard voting and soft voting. Yeah. Hard majority. Okay. Hard voting basically means just take the aggregated result of the final output. Soft voting basically is going to look into the values of each of the output. For taking the decision in each of the model, we will look into the output, right? And based on the output, you are going to take the final decision. So those values are considered. In other words, we can say weighted average is used for soft voting, whereas hard voting is just the aggregated result of the final output of all the models. Right. Next. What is random forest, or how is random forest different from bagging? How is it different from bagging? Bagging is also a combination of multiple decision trees. Decision tree also has with replacement option. Reduces the overfitting problem. Bagging also does that. Very good. Kiran Kumar, very good. Funny Kiran, good. So the random forest that we are talking about is a variant of bagging approach. It's an example of bagging approach. In bagging approach, we are basically developing multiple models on the samples, and then those multiple models will be used for predicting the output or classifying the output, and the aggregated result will be used for taking the final decision. That is bagging approach. Now, a variant of this approach is random forest, in which when you are taking the sample data, in random forest, only a subset of columns will be chosen for a sample. When you are developing sample, when you are coming up with sample data, only subset of values are chosen. Right? So that is the primary difference of random forest with respect to bagging approach. Okay. What else? I think nav based we covered few questions yesterday, right? All right, fine. For random forest, what is the library? No. R package and Python library, guys. Python package. What are the packages used for random forest? Party, okay. Random forest itself is one of the libraries that we can use. Yes, now very good. With capital F. Random forest with capital F. And in Python, we have sklearn.ensemble. Very good, Chaitanya. sklearn.ensemble. And the function we use is random forest classifier. Random forest classifier is used. Right. So that's about, let's say, random forest. Anything I'm missing? Okay, fine. Okay, what is the default number of trees used in random forest? Very good, 500. In R, for example, yeah. If we talk about R, yes, it is 500. But what are the default number of variables which are used? By default, what is the variable size that is used in random forest? Okay. Okay. Square root of p is okay. We also have p by 3. Two options. P by 3 is also there. So when your data is categorical, we go with p by square root by 3, square root of 3, sorry. If your data is numerical data, then we go with p by 3 features. Very good. Okay. Fine. Okay, let me move on to the regression related questions. One of the very, very popular techniques. Yeah, Suresh, I was about to. So we'll move to regression techniques. A lot of, as I said, this is the most popular. Regression is the most popular explainable statistical model, which is used for predictive analytics. Right? And yeah, these are the interviewer's favorite questions as well. So before that, let's take a short break and come back. So it's 11:31 now. Let's connect by 11:38. Yeah. Okay, hope everyone is back. All right. So now let's talk about the regression related questions. When do we go with regression? Yeah. We can also go with KNN. We can also go with decision tree. Linear, not really, not required. Linear correlation, not really, right? No. When output variable is numeric in nature, we apply regression techniques, we go with regression techniques when output variable is numeric in nature. Right? Then what regression technique we apply when output variable dependent variable is continuous? Simple, very easy, linear regression. Linear regression is based on what mathematical equation? Y is equals to mx plus c. Very good. Equation of a straight line. Predefined equations. Next. What is the bare minimum requirement for applying regression model? Minimum requirement. Okay, very good. It should have two variables. And numeric, again, I'm writing the same, I'm asking the same question in a different way. Minimum required applying regression is, what is the bare minimum requirement for applying regression is that bare minimum requirement of applying regression is that the data should be numeric. Now, how can we achieve good fit? For linear regression. How can we achieve good fit for linear regression? How you achieve that? Read the question carefully. How can we achieve a good fit for a linear regression? How can we achieve a good fit for linear regression? How would you fit the line? Nobody's giving the answer. These are all the measures to interpret the goodness of fit. I'm asking, how do you achieve that? Transformations, guys. Transformations. Yeah. Okay. So what does transformations or transformation technique do for linear regression model? What does it do? It improves goodness of fit to the data. How? By altering the distribution of the data. Right. What are scatter plots? Okay. Very good. Scatter plots are a bivariate visualization techniques which help us interpret the relationship between the variables, between the two variables. What all things scatter plots help us interpret? Kiran is right. Very good, Kiran. They will help us to interpret the relationship, that's linearity. Then it also helps us to interpret the direction of the relationship and the strength of the relationship. Of course, the strength will always be subjective, but at least at a high level, we will be able to interpret the strength. But it also tells us the cluster formation in the data. Scatter diagrams will also help us identify the clusters for a bivariate data. Yeah. Next, how should we interpret the linearity between two variables? How should we interpret the linearity between the two variables? We're trying to check the linearity between the variables, right? But how should we interpret that? Not really. Okay. Why should be linear with the coefficient with the parameters? Okay, positive slope. No. What is linearity basically telling you when you look at the scatter diagram? We're looking for linearity, right? But what does that actually mean? Of course, relationship. Yeah, but how do you interpret it? Very good. Now, Preet, yeah, you're on the track. What happens to output when input changes? Proportional relation. Okay. Getting close. Bhavna is right. Equally, consistency. When y is changing and that y is changing because of the change in x, then how is that change, right? How is that affected is what we are trying to identify. That's what relationship interpretation is all about. Now, when you say linear relationship, we are trying to understand how consistency or what kind of consistency or how consistent is that cause and effect between x and y. Linearity is basically speaking about that consistency. What does correlation does not guarantee causation means? The component, okay. What does correlation does not guarantee causation means? Correlation is a measure which can be calculated by substituting the values, numeric values, into a predefined formula. But that doesn't explain the relation between the two variables. Scatter diagram is showing the correlation. Correlation coefficient is a mathematical calculation, but these two will not explain the cause and effect relationship. That has to be interpreted. That's correlation does not guarantee causation means. Next. What is OLS? Ordinary least squares. Very good. Why is it used? Very good. Ordinary least squares is a technique which is used to fit a linear model onto the data. The objective of OLS is to find the best fit line. How does it achieve the best fit? By reducing the residuals. It is trying to minimize the residual. That is nothing but sum of the squared errors, variance. right? It finds the best fit line by identifying the line which has the least variance. And in order to capture that, it does the squared calculations of errors, right? Yeah. What is or what are the properties of errors? Important question. Yesterday also we discussed this. Very good. IID normal. The errors in the first place should be normally distributed. The mean of the errors should be equal to 0. They should be identically distributed, independently distributed. They should be identically and independently distributed. What are the assumptions of linear regression? I should say linear regression. Line, right? Very good. Line assumptions: linear, independent, normal, and equal variance. What are the challenges with linear regression modeling? What challenges can you encounter? Very good. Okay, the challenges are, to start with, we have autocorrelation problem, we have heteroscedasticity problem, we have collinearity problem, right? And of course, any other assumption, any other challenge that we see can be fitted into one of these three also, right? So challenges, and what is the solution for all these challenges? Transformations, very good. Wonderful. What is the measure of correlation? Small r value, very good, Bhavna. What is the range of small r? -0 to 1. Why 0 to 1? -1 to +1. What is the shape of the line, or shape of the relation between the two variables if the correlation is equal to 0? Very popularly used question, regularly used question. Very good. Straight line parallel to x-axis. Right? Horizontal line parallel to x-axis. Very good. Okay, what is difference between correlation and covariance. Very good, Salvan. Correlation is the strength of the relationship between the two variables and the direction also. Correlation also talks about direction. Whereas covariance is only talking about the relationship. Right? Another property, yes, Fanikira. Correlation is a unit-free value, whereas covariance is not unit-free. Next. What is the difference between adjusted R squared and multiple R squared? Yeah. Very good. Okay. All right. Adjusted R squared is calculated or I should say it is identifying the significance of the input variables. Right? Whereas multiple R squared or simply R squared, it is only looking at your, I should say, number of features. It only looks at the count of the features. Yep. Okay. Oh yeah, formula, yes, that's correct, Kiran. Adjusted R squared is 1 minus 1 minus R squared by you say n minus p minus or k minus 1. Yeah, you represent that as different value, k or p. Okay. What else do we have? Okay, one more question. Can adjusted R squared be greater than R squared? No, you cannot. Adjusted R squared will always be lower than your regular R squared, multiple R squared. Or it can be maximum equal to. It cannot be greater than. Right, yeah. Okay, what else do I have to talk about in regression? Okay, what is the error function here? Or what is the cost function in regression? Yes, RMSE. Okay, this basically calls me with another question. What is the difference between residuals and errors? Yeah. Very good. Okay, Rabi, then what is error? Very good, Bhavna. Wonderful. Wonderful, wonderful. All are correct. So residuals are calculated on the data which is used for training the model, whereas errors are calculated on the data which is a new data for the model. Right? As the name suggests, residuals means leftover. When you are training the model, you were not able to capture those values. So it is left out. Right? That's the reason why it says residual. And error means when you are trying to predict something, how deviated your prediction is when compared to the actual value. Right. Next. What is beta value? Or how beta value is interpreted? Or I should say, in the equation. I'm saying beta. So your linear regression equation, when you talk about, we have y hat is equals to beta naught plus beta 1x, right? So I'm talking what is the beta value here? Beta is this, not beta naught. The beta naught is an intercept, constant, right? So, okay, let me split this question. Let me write a question here. How or what is beta naught or intercept? How do we interpret that? And what about the beta values in the equation? Slope in the equation. Beta naught. Very good, Santosh. But what is beta naught? Yeah. What does that mean, Ravi Kumar? Constant or mean. Very good. Beta naught is the base estimation. Vanilla estimation, vanilla model. That means if you're not passing any input variables, if you're not considering any of the factors influencing the y, then the estimation of the y is beta naught, which is nothing but average. That's how we estimate the value, right? So for a univariate variable or a univariate value, if I have to estimate, then I use beta naught. That's nothing but average. Now, what is beta 1? How do I interpret these slopes? So it is basically the value of change in y when your x is altered by 1 unit. So x is altered by 1 unit. That implies y is getting impacted by beta units. Right? That's how it is interpreted. Right? So that's how we interpret the beta values. Now, what is the OLS beta values considered as? I didn't understand that, Kiran. Can you reframe the question? Okay. So we have OLS technique, right? Which is giving us this equation. Right? And you get beta values in it. So how should I interpret that beta values which I'm obtaining from OLS technique? No. Beta values. I'm talking about beta values. Yes, they are coefficients. Not really. Okay. So maybe the question is a little twisted here. Let me answer that question. The beta values that we are obtaining in the OLS technique are considered to be the unbiased beta values for parameters. We are estimating the beta values, right? For a given sample. So the regression line that we are creating here is based on the training we are doing on a sample. But what if the sample varies? My training varies, so beta values will change, right? It will change. So the OLS technique is giving us the best estimation of beta values for population. And we say unbiased. Confidence interval. So unbiased estimates of population based on this sample. Making sense? So if I change the sample, my beta values will also change. Irrespective of that change, when I want to find out a regression equation, the OLS technique is finding out the beta values for as a population estimation. And how do I measure the significance of beta? T statistic, of course. P-value. P-value is used to interpret. For significance test of beta values, t value is used, and we interpret the p value for each of the coefficient success criteria, right? And this p value should be less than 0.05. Yes. What if the test is failed? We do feature engineering, very good. We do applied transformation techniques. Yes. We cannot simply, removal is the last option that we need to go with. Remember that. Removal is the last option. Okay. What is collinearity or multi-collinearity problem? Yeah. When more than two variables are linearly dependent among each other, independent variables. How do I interpret multi-collinearity? How do you check for collinearity or multi-collinearity? Very good. Scatter diagram, which is basically performed for all the pairs. Pair plot. Then we also check for correlation coefficients. And we also check for VIF. We also check for partial correlation. We also check AV plots. So many things are there to interpret collinearity, but specifically the collinearity can be interpreted by looking at scatter diagrams, correlation coefficient values, and VIF values. These are the three techniques that we can check for collinearity problem. Of course, Kiran, yeah, that's also right, yeah. F statistic is significant and T statistic is not significant. How do we verify for autocorrelation problem? How? How do we check? When errors do not have zero mean, no, that means a biased model. Okay. No. Residual plot. Residual plot. Can verify autocorrelation using residual plot, which is basically a visualization or a scatter diagram of observed values and fitted values and errors. And we check for any kind of pattern in the data. Yeah, so that's your autocorrelation. How do we check for heteroscedasticity? Scatter diagram, very easy. Funnel shape distribution in the scatter diagram. Very good. What is partial correlation? Okay. Okay. Correlation of one variable. Okay. Okay. So partial correlation measures the strength of a relation between the two variables, right? In that entire equation, when others are also contributing. So you have one output variable which is getting affected by multiple input variables. Then what is the partial effect of one variable on that output? That's your partial correlation. Whereas correlation is only between X and Y. Partial correlation says in that entire equation that we have, this is your equation, so on and so forth, then what is the effect of X1 alone on Y in the entire equation? Because X2 is also contributing to some change, X3 also will change affect, right? So what is the effect of X1 alone on Y? That's your partial correlation. What is AB plots? What are AB plots? Added variable plots, what does that mean? Partial regression plots, very good, okay. Exactly. It is a visual representation of the same partial correlation that we were discussing just now. What is the impact of one variable on output variable when others are also influencing? How do we calculate VIF? Very good. One by 1 minus capital R square, not small r square, capital R square. The full form of VIF is variance inflation factor. Right? And the thumb rule says, if VIF is greater than 10, then means it is having multicollinearity problem. Okay. So when you are developing linear regression or in linear regression, or in regression rather, how do we counter overfitting problem? Regularization techniques. The tuning parameters are applied. Regularization techniques. What are the L1 norm and L2 norm? L1 norm and L2 norm. L1 regularization. What does L1 regularization means? Yeah. L1 means lasso regression in which absolute value of coefficients is added as a penalty term. If lambda is equals to 0, then it becomes, if lambda is equals to 0, then the cost function is OLS. Then it is OLS technique. Very good. What is the cost function for L1 norm? What is the cost function for L2 norm? Yeah. Modulus penalty term is added to the cost function of OLS, and that penalty term is absolute value of coefficients. For L2 norm, the penalty term is squared values of the coefficients. L1 norm is also known as another name, lasso regression. L1 norm or lasso regression is also known as shrinkage method. It's also known as shrinkage method. What are the two types of approaches for feature selection? in regression. Or feature selection approaches. Forward feature selection, backward feature selection, right? Yeah. Very good. What else? What else? What else? Okay, what is the difference between AIC? What is AIC? Archaic information criterion. Yes. It is a measure of goodness of fit. Right? It is a measure of goodness of fit. Model comparisons. Yes. And the interpretation is lesser the AIC value, better the model. Now, what is BIC? We also have something called as BIC, right? Difference between AIC and BIC. AIC is archaic information criterion. What is BIC? No, not beta. Bayesian. Bayesian information criterion. Bayesian information criteria is also a technique which is helping us to do a model selection with different number of parameters. Yeah. BIC is an approach which basically penalizes the parameters very effectively rather than AIC. I mean, compared to AIC. Right? Yeah. Next, what can I think of? Okay. What is MLE? Maximum likelihood estimate. Very good. Yeah, very good. What is the difference between prediction interval and confidence interval? Yeah. Okay. Prediction interval is interval which basically speaks about a point estimate value falling in that interval. So it's an interval which is verified, or which is a single point falling in that range. Whereas confidence interval is basically a average value falling in that range. Confidence interval says average outcome falling on in a specific range. Right? So prediction interval takes each value, whereas confidence interval takes the average outcome. Yes. So your prediction interval, which one has more margin, more value, prediction interval or confidence interval? Prediction interval. Prediction interval. Individually, it has to verify for the values, right? Whereas average means it's averaging. The wider range is getting smaller when you take average. Okay. And okay, what is deviance? Now we talked about MLE, right? Logistic regression. What is deviance? Deviance is measure of goodness of fit. It is the error, right? Oh, how many type of deviances do we have? Two. What are those? Null deviance and residual deviance. Very good. What is let's say link function. What is a link function? Yes, Kiran, that's correct. Yeah. No, Bhavna. In logistic regression, what is link function or probability function? E power y by 1 plus e power y. Or you can, yes, Santosh, that's also right. 1 by 1 minus e power minus y. That is also correct. Probability function or link function is e power y by 1 plus e power y. Okay. What is odds? If I ask this question, then you should say P by 1 minus P. Very good. What is logic function? Log of odds. Very good. Logic function is log of odds. What is cutoff value? Yeah. What is cutoff value? Threshold value, okay. Okay. Cutoff value is the value which is deciding whether an event is a true event or not based on the probability of the logistic regression output. Logistic regression gives only the probability of an event occurrence, right? So cutoff value is deciding, or cutoff value is the margin which decides whether the event is a true event or a false event. Okay. What is stratified sampling? No, stratified sampling is not a biased sampling. It is unbiased sampling only. Yes. Stratified sampling is the sampling technique which maintains the proportion of the categories in the subsamples or in the samples. Yeah. So it first splits the data based on the stratas. Those stratas are nothing but the categories in your output variable. And from those stratas, the proportion of categories are chosen in such a way that it reflects the population proportions. So stratified sampling is a sampling technique which maintains the proportion of the categories of your variable of interest in your sample data. It will be equal to population data is what I mean. Right. Next. What is ROC curve? We discussed this also yesterday. ROC curve is receiver operating characteristic. And why is it used for? It is used for identifying the appropriate cutoff value. What are the parameters or what are the metrics used in ROC curve? What are the metrics used in ROC curve? True positive rate and false positive rate. Yes. On y-axis, we'll have true positive rate. On x-axis, we'll have false positive rate. Okay. What is precision? Very good. True positive by true positive plus false positive is the precision. How do we explain it? How do we explain precision? Measure of positive rate. Okay. Okay. It is the actual positives being correctly predicted as positives out of all the positive cases. So we are predicting positive, right? How many of those positively predicted cases are actually positive? Or in other ways, we can say a random observation which is being predicted as positive being in actual positive. Or in other ways, a random observation which is a true, which is a positive, true positive observation being correctly predicted as positive. True positive by positively predicted cases. All piece, precision. Okay, very interesting question. I just kind of remembered it. What is the difference between probability? You know probability, right? You people know what is probability. What is probability? The number of interest events by the total events, or the chance of occurrence of a specific value. Now, what is the difference of between probability and likelihood? Yeah. Probability, you know. What is the probability of likelihood? Okay. Okay. No, not really, Bhavna. Okay. Probability is a measure based on the number of possible outcomes, right? Here, we are not looking at any observed data. I mean, we are not, I should say, yeah, conditions, you can say, yes. Probability is just based on the historic data. We are looking at the possibility of the outcome of an experiment, which value has a higher chance and all that. Whereas likelihood is the possibility or the chance of an output given specific observed data, given certain conditions. Right? In statistical terminologies, if I have to specify this, then we can say probability basically is explaining the chance of a random value as an outcome. Right? Given, I should say, a value, but without any reference to the observed data. So I have, let's say, flipping of a coin. Yeah, if you're flipping of a coin, if you flip a coin, then you're looking at the possibility of outcome. Right? Simple probability. Likelihood is basically saying what is the chance of this coin flipping and getting a heads if a certain condition is levied upon. In certain scenarios, what are the chances that you have that a specific value has an outcome? Yeah, so it's a kind of, I should say, a similar aspect. So likelihood basically is like a hypothesis. Yeah. It's more like likelihood. Likelihood is more like, I should say, yeah, likelihood, probabilities are also not mutually exclusive. Let me think of an example here, okay? Probability, can I give any example? Probability is very simple. Likelihood is more like a hypothesis scenario. Cannot think of an example straight right away. Cricket match. I mean, you see, you have a possible range in hypothesis, right? Probability is a specific result, whereas hypothesis or likelihood is basically associated with the range of values. That's something that we can try and imagine there. That's something that we can think of. Yeah. Likelihood is more like trust. Kind of, you can say. Probability of winning the toss and likelihood. Yeah, very good. Yeah, Lokesh, you can. That's an absolute thing. So if you're flipping a coin, you will get head or tails. Right? So you are directly calculating the probability of winning the toss. It gives you the result. Probability gives you the results. Whereas likelihood means the chance of having a specific value. What is the chance of winning the toss? Likelihood. Yeah. It's a kind of right tricky difference. You have to read about this. I would recommend reading about this a little more. In simple terms, probability is a straightaway calculation that you do. It directly attaches to the results. Whereas likelihood means it's basically hypothesis. You are referring to the conditions. Okay. All right. Okay, next. Probably I'll come up with some examples in the document that I'm gonna post it on the website. Okay, so you have the learning resources here, right? You see interview questions. There are few interview questions here. So in this section, you will have all these questions coming up. Whatever the questions that we are discussing, right? Those questions will come in this section. All the questions that I'm writing on the Word document, they will be there. Yeah. Okay. Anything else that I'm missing? Any questions that I'm missing? Okay, what is baseline or reference, guys? Or what is multi-logic? What is multi-logic? Of course, yeah. Multi-logic, it generalizes logistic regression to multiple class problems. Of course, yes. Okay. So multi-logit is an extension to logit function. And logit function talks about log of odds. Multi-logit was also talking about log of odds. But when we talk about log of odds in greater than 2 categories, then we need to refer to that log of odds with respect to a specific baseline. So we have a baseline here. What is baseline or reference? In multinomial regression, what is baseline or reference? Yeah. Difference, guys, come on. Baseline is one of those categories in your output variable. When you have greater than 2 categories, one of the category is chosen as a reference or a baseline, which is used for comparison when you are calculating the log of odds. Right? So from that baseline, we get multi-logit. So what is logit? Logit is log of odds. But what is odds? P by 1 minus P. Now you are able to calculate this because you have only binary cases here. Because you have binary cases, you can say P and Q, where Q is equal to 1 minus P. That's what you are writing here. But when you have greater than 2 categories, can you say probability of other events? You'll have P1, you'll have P2, you'll have P3, you'll have P4, so on and so forth. Maybe I can say P1, but can I calculate P2, P3, P4? Not possible, right? In binary, I can say. So here, in multinomial regression, one of the categories is chosen as the baseline. So category A, category B, category C, so on and so forth. If I have this, one of these categories is chosen as baseline. Log of odds, but that odds is probability of A. Given, or let's say A is the baseline, we'll choose A as the baseline here. This is baseline. Then what is the probability of B, given of course the other parameters, with A? Log of odds. It's nothing but P by A, P by Q, right? So here we are writing probability of B by probability of A. Similarly, probability of C over probability of A. So you can see A is constant, right? This is baseline. So what are the chances, log of odds of a customer preferring this category over this, preferring this category over this, right? So that's your logit, multi-logit function. Now, what is odds ratio? We're talking about odds. What is odds ratio? So I'll write this. What is odds and what is odds ratio? Yeah. What is odds? It's the ratio of the chances of an outcome over the chance of event not occurring. Right? Probability of an event occurring by probability of event not occurring. It's a ratio of probabilities. But what is probability ratio or odds ratio? That is odds, Kiran. What is odds ratio? No. So odds ratio basically is the ratio of odds. Right? Odds itself is a ratio which is basically talking about probability of success by probability of failure. But this probability of success over probability of failure, given a condition, right? Given some condition, we generally use a term called exposed, presence of an exposure. For example, what is the chance, what are the odds of a male person, or let's say what are the odds of a person getting COVID positive, when I say odds of COVID-19, you will say probability of positive divided by probability of negative. This is odds, right? But I'm saying when the person has traveled, when the person did not travel to China, let's say the person not traveled to China. But what are the odds when the person has traveled to China? This is odds ratio. It's a ratio between odds having a specific condition when exposed and when not exposed. Odds ratio is different from odds. Remember that, okay? Yeah, odds before traveling versus odds after traveling. Very good. Ratio between odds before traveling and odds after traveling. That is also an odds ratio. All right. Fine. We'll wrap up the session for the day. And we'll try to have these sessions more. Exceptionally good, Kiran, but yeah. Still, there are a lot of things. I'm just trying to touch base only on the concepts which are very, very high level used. You have to deep dive into various aspects also, right? Especially with the arguments. Okay, that's a suggestion. In fact, we did not do the programming part yet. We did not do black box yet. We did not do forecasting, right? So there are a lot of things that we need to cover. And whenever we talk about any of these algorithms, focus on the arguments and their effect, regularization techniques and their effect, tuning parameters and their effect, right? These are few of the concepts that you have to focus on. Right, yeah. Aditya, these sessions are available on your LMS. Yes, they are available in YouTube, and the access to these are provided in your LMS recommended videos. You can check that. We'll communicate, Sabin. We'll communicate, yeah. All right, friends, keep studying, keep practicing, keep learning. Every day is a learning. Make sure you are prepared well. Be ready for your interviews. Yeah, thank you, Kiran. Yeah, I've randomly created the questions. I'm not prepared, okay? These are some of the questions that I keep asking students. So, yeah. Sure, yeah. These questions, please go through these questions. These will be uploaded here in due course of time, probably in a couple of days or maybe 3 days at max. In this coming week, we'll have these questions uploaded here. Till then, please go through the YouTube videos. And all right, guys, thank you. That's all I have. Thank you all. I will inform Ayush.